All right, let's try to finish up. Well, we won't finish up. We'll get a big chunk of it done, though, like I said earlier, of this. That's why I call it 3.5b. Let me get my notes where I want them. Let's review just briefly what we did yesterday. Okay, so I asked you yesterday to graph something, and I put it in a certain form. Do you remember what that form was? It was y equals what? Good. Y equals mx plus b. All right. So that's called the what? Do you remember what we call that thing? Very good. Slope-intercept form. I'll just shorten intercept to that. All right, so that's called slope-intercept form. Okay, we learned how to graph from the slope-intercept form yesterday. If you were not here yesterday, then you watch the video and it's on there. All right, so let's just make something up. Y equals, I don't know, 2/5 x minus 3. Okay? So if I asked you to graph that, it should be pretty easy. You really don't have to do any math. You should just be able to look at it and then plot a couple points, connect the points, and you're done. That's really, for an equation in that form right there, that's really all you need to do. You just got to count. That's all you got to do. You just got to know where things are, and you got to count. So let's do it. What's the first thing? What? I don't have a pencil. So everybody look up here. So the first thing that you're going to plot is this. What is that thing right there? Yeah, it's a -3, but it's the y, not axis, it's the y intercept. Intercept, okay? That's why it's the slope-intercept form. This is the y-intercept. What does that mean? It's kind of like the word intersect, isn't it? Okay, it's where it goes through the y-axis. So where does it go through the y-axis? At -3. So this is the y-axis. So you come down here to -3, 1, 2, 3, and you put a point. And you're halfway done. Basically halfway done. Okay? Everybody can do that, right? Just look at that last number, and then you put it on the y-axis. Make sure it's on the y-axis, not the x-axis. We're going to talk about that in a few minutes, the x-axis. But this is the y-intercept, so we put it on the y-axis. What is this thing right here?
Rise and run.
Yeah, but we say it's the what? Yeah, m, which is, I'll tell you what, I'll write the word out, which is slope. And what letter do we use? We use m to represent the slope. And you said it. How do we think of the slope? We rise over run. Okay? Everybody got that? So how do we graph it? Super easy. You put a -3 at the y-axis. That's the first thing. And then from the -3, don't start at the origin. I've had kids do that. Start at the y-axis. And then what do? We rise 2. So we go up 2, 1, 2. And then we run 5. That means we go to the right 5. 1, 2, 3, 4, 5. And then you put a point right there. And what do you do with those 2 points? Just connect them. Make a line out of it. All right? Connect it here. And then there. Should be pretty close. All right? And put a little arrows on the ends just to make sure it's a line. And you're good to go. It's pretty simple, isn't it? What do you think? Yeah, I mean, what's hard about that? It's really nothing. You just have to know what these things represent, okay? As long as you know what these things represent, it's very easy to do it. So again, what do? Look at -3, put a point right there at -3. Look at this number that's right in front of the x. It's 2/5. That means it's rise over run. It's slope. So we rise 2, we run 5, put a point right there, connect the points, bang, you're done. Simple. I don't think I'm just saying simple because I'm the math teacher and I know how to do this. Do you agree that that's pretty simple to do? Yeah, I think so. Let's do one more just for fun, okay? And then we'll get to some newer stuff. And let's get rid of this. Let's get rid of this. And let's make this white. All right, so here's another one. Let's make it another color. Let's go green. So let's graph this. Now this might look a little different to you. Let's graph y equals 3x plus 4. What if I asked you to graph that? So what's the first thing that you're going to look at? The 4, the y-intercept, which is a positive 4. So what does that mean? We go on the y-axis, go to positive 4. 1, 2, 3, 4, put a point. We good so far? Yes.
Is it like a straight line?
It is going to be, well, they're all straight lines.
Right, but like,
All lines are straight.
just like, I don't know.
Like horizontal, vertical? No. Because it does have a slope. What's the slope? Is it?
3.
The slope is this number right here. What's that number right there? It's 3. But remember what we said earlier? It's rise what? Over run. Well, which one's the rise? Which one's the run? Well, no, it's not the x. We're just looking at the 3. The x and y are just window dressing. All right. It's 3 what? Over 1. Very good. Ariel got it. 3 over 1. Isn't that the same thing as 3? Yeah. All right. So that's a little bit tricky sometimes because you're used to seeing a top and a bottom, right? But they could have a whole number. It could be a negative as well. All right. But it's 3 over 1. So what am I going to do? Go to the y-intercept and do what? Go rise 3, 1, 2, 3, and run 1. And then connect them. Okay? See how close these are together? Sometimes your line doesn't, it looks like it matches up because your dot's kind of big, but it might slant a little bit the further off it goes. So what I like to do sometimes is I went 3 over 1. You could stretch it out a little bit and do what? Go down 3, 1, 2, 3, and to the left 1. Do it a couple more times. 1, 2, 3, 1. Let's do it one more time. 1, 2, 3, 1. Everybody see that? Did you see how they all still line up? But now that helps us make it just a little bit more accurate the longer you draw that graph. You see that? So that should be a lot more accurate. Maybe not a lot more, but at least a little bit more accurate, drawing it like that. And that's all there is to it. Okay, y-intercept, slope. Can everybody handle that? Yeah, that's pretty easy. All right. So that's the beauty of the slope-intercept form, because you really didn't have to do any math, did you? Okay, all you had to do was look at it and say, oh, that's the y-intercept, bang, put a point right there at 4. That's the slope, 3 over 1. So I rise 3, run 1, bang, put a point right there. Connect them, and you're done. That's all there is to it. Super easy. Slope-intercept form is very valuable. It's used all the time. It's one of the big, famous, if you want to call it, equations in math. All right, especially in lower math like algebra 1, algebra 2, stuff like that. All right, geometry. All right, so it's very well known. This is not just an obscure little thing that we're doing. This is like a big time thing that we're doing right here. Okay? Everybody got it? All right. So now what we're going to do is this. So let's copy this because I'm going to use it again. And let's scooch down a little bit. I got another form that we're going to do. So the first form we did was slope-intercept form. Usually I teach it the other way around. The one that we're going to do right now I usually teach first. But then yesterday when I was thinking about it, I was like, you know what? I think the slope-intercept form is easier. So I'm going to teach that first, and then I'm going to go to the one we're going to do right now. So normally I would teach this first, but they call this the standard form. Standard form of the equation of a line. So if I wanted to go all out, I would say it's the standard form of the equation of a line. The equation of a line tells you some things about it. So here's what the standard form is. All right, so write it down. So it's AX, and it's a capital A, make sure you make that capital, plus BY equals C. All right, that's it right there. Now, it probably means nothing to you, and I can understand that. I understand why it would mean nothing to you. But hopefully, by the end of this, you'll see how it's used and how we can write an equation of a line using this. Let me say a couple things first. The A, the B, and the C, the A, the B, and the C have to all be integers. And what's your first question? What's a what? What's an integer? Okay, was anybody thinking that? Yeah. So, let's talk about what an integer was. When you were younger, probably before Algebra 1, I would guess. Didn't you learn this? Little number line. So if that's 0, what's this one right here going to be? 1, 2, 3. And what's this one going to be right here? -1, -2, -3. All these numbers right here. Now, does it just stop at 3? No, that arrow means it does what? Keeps on going. And a lot of times we'll put a ... What does a ... represent? That it keeps on going, right? And same, you could go this way too, couldn't you? Because the negatives go to the left. That means it keeps going that way. Do you see all these numbers right here? What do you think they're all called? Integers. They're all called integers. Okay, question? Somebody had a hand up?
So, sorry, going back to the form,
Yeah.
is X, Y there just because last time just to look fancy, or is that the X and Y actually?
It kind of is. It represents a point on a line. That's the answer to that question. Don't worry too much about the X and the Y right now, okay? I think we'll talk about, I don't even know if we'll talk about it in this lesson, but maybe another lesson we'll talk about that a little bit more, okay? But for right now, yeah, just think of it as window dressing. It's just there, okay? But it's not just there. There is a reason for it. But I just don't want to get into it right now. But a good question, though. All right, so A, B, and C have to be integers. So A, B, and C cannot be a what? Look, what's not included? Is 1 really the next number after 0? Is 2 really the next number after 1? What could be in between? Yeah, 0.5, which means decimals or what? Fractions. That's right. So an integer is not a decimal and it's not a fraction. Everybody with me? Now, somebody would say, well, what about 4? Is 4 an integer? Yeah, but somebody might say, well, 4 over 1, that's a fraction. Or 8 over 2, that's a fraction. But what does it reduce to, though? It reduces to just a 4, right? So really, technically, it looks like a fraction, but it's really not. Agreed? Okay. So these all have to be integers. So no fractions, no decimals. All right. Now, there's something extra special about point A. Point A has to be a positive integer. Okay. I'll just put int. Let's write it out because you could think of that as intercept. Integers. Did I spell that right? Yep. Everybody with me on that? So, for instance, what if I had something like this? What if I had 2/3 x minus 4y equals 5/7? Is that in standard form? You guess? Think about what we just talked about. This is our A. This is our what? B. And this is our C. Thank you. All right. So is that technically in standard form? What do we say? What are some of the things that has to be true about standard form? That's right. You can't have fractions. Do we have fractions here? Yeah, we just finished talking about that. So you have fractions. Is this in standard form? No. All right. What about this? What about -3x plus 2y equals 4? Is that in standard form? Why not? Who said it? Isabella, what? Say that again. Oh, it needs to be positive. Okay, I didn't get that last part. Yep, you're right. This has to be positive. So this technically is not in standard form. Why not? Because A has to be what? It's got to be positive. Is it positive? No, it's not. All right, what about this one? Is that in standard form? Absolutely. Okay, so that is in standard form because there's your x and your y, there's your plus, right? So what's your A in this situation? It's 5. What's the B? +3, and then the C is 7. Everybody good with that? All right. Now, what do those numbers mean? What do they represent? Unfortunately, unlike the slope-intercept form, you can't just look at A, B, and C and just put that point on the graph. You're going to have to do a little bit of math, all right? That's why I like the slope-intercept form, because you can just look at it, put a point here, find the slope, put a point there, connect them, you're good to go, all right? On this one, though, you got to do a little bit of work. It's not much work, but it's a little bit of work, all right? So let me, before we actually start doing this thing, let me just do one more thing. And I think this will help. I hope it will. I think it helped the other class. What if you had a line? I'm just going to draw some random line. I could go this way or this way. I'm just going to draw it this way. All right, so what if you had a line right there and right there? Okay. We've already talked about this once today, and we talked about the second thing very, very briefly yesterday. But this, what would I call that point right there? Now, I don't know how far up I went, but I would call it the what? The y-intercept, exactly, thank you. So that's the y-intercept. Everybody see that? So what do you think you would call this point right there? Call that the x-intercept, very good. Okay, why? Because this is where the line crosses what? The x-axis. This point right here is where the line crosses the y-axis. Good, I like it. All in unison, perfect. That's what I want to hear. All right, now let me talk about this point right here. If I wanted to figure out what the ordered pair was, now I didn't say how far I went up, right? I could have gone up 1, I could have gone up 2, 3, 4. I don't know how far that is. But I do know if I start here, what do I do first to get up to that point? I got to go x and y. Remember, this is x and y? Okay. How far on the x-axis do I have to go? How far on the x-axis do I have to go before I move up? I go 0. Very good. 0. Okay. So 0. Now, how far up did I go? I don't know. I don't have any numbers in there, do I? But I go up as far as I go on the y-axis. So we'll just call it y. Is that all right? That could represent any number. It could go up 1, go up 2, go up 3. That y represents how far up you go. Or down, right? This could have been down here, all right? You with me on that? So this is the y-intercept. The x is going to be 0 on any y-intercept. Would you agree? What if this was my y-intercept? This is still 0 something. Right. Everybody see that? All right. So any point on the y-axis is always going to be what? 0, whatever. Okay? Everybody good with that? All right. I'm getting somewhere. Okay? Hold on. I'm getting there. What about this point right here? This is my x-intercept. Is it 0x? Remember, I always go in the x direction first, then the y. So I go what? To here, which would be, yeah, it's negative, but I'll just say x. X could represent a negative. All right. And then I go how far on the y? I go 0. That's the key right here. All right. So that's my x-intercept. Okay. So the the y-intercept, what is 0? What is 0? The x or the y?
Oh, sorry.
The x is 0, right? So to find the y-intercept, what you're going to do is you're going to set the x equal to 0. In order to find the x-intercept, you're going to do what? Set the y equal to 0. So let's write that down. I'll do it in white. So let's do x-intercept first. Okay, in order to find the x-intercept, what do? We set the y equal to 0, the other one, right? To find the x-intercept, we set the other one equal to 0, and then we can find whatever the x is. Okay, we're getting really close to actually doing a problem here, okay? All this is building up. I know the excitement is just way too much for you, but we're going to get there in a second, all right? Now, how do we find the y-intercept? We set what? Set x equal to 0. Good. See that? In order to find this point right here, what did we make 0? The x. How do I find this x-intercept right here? What do we set? We set the y equal to 0. Thank you. Everybody got that? So that's super important. What I did right there, I'll put it in a box. All right? Anything in a box always means it's important. Wouldn't you agree? So write it down. Okay, to find the x-intercept, you set y equal to 0. To find the y-intercept, you set x equal to 0. So if I knew what the x-intercept actually was, I could just put a dot right there. If I knew what the x or the y-intercept was, I could put a dot right there. And then all I got to do is connect those two dots, and I got my line. All right. Now what everybody's been waiting for. Okay, I'll keep it right there. Tell you what, I'll just get rid of this stuff just to get it out of the way. All right. So what we're going to do is we're going to take this and we're going to use it to graph an equation. Now, remember we talked about that standard form? This graph is going to be written in standard form, or this equation, I should say, is going to be written in standard form. So is that in standard form right now? Yeah, because they're all integers, there's no fractions, the a is positive, so yeah, this could be negative, this could be negative, it's fine. All right, as long as the a is positive, that's in standard form. So what I'm going to ask you to do is I'm going to ask you to graph this using x and y intercepts. So write that down, because that's how they're going to ask on the quiz or test and homework on some of the problems. Not all of them, but some of them, they're going to ask you to do it this way. Because looking at these right here, that 2, that -3, that -6, like, does any of those represent like the y-axis or the y-intercept or the x-intercept or any other point on my line? Does anything on here represent the slope? No. I can't just look at it the way it is, right, and say, oh, I put a point here at -6, or I put a point here at 2, or the slope is this. No. You really can't just look at it, at least right now. You can't just look at it and then just graph it. With the slope-intercept form, you could do that, couldn't you? You could just see the y-intercept, bam, put a point. See the slope, rise, run, bam, put a point. Okay? And then you got your graph. This, you got to do a little work. So first thing we're going to do is we're going to find the x-intercept. So what do we do? It's in a box. Big hint. It's in a box. What do? We set y equal to 0. Set y where? This equation right here. Okay? So what we're going to do is we're going to rewrite this equation, but instead of y being y, what's y going to be? 0. Good. So let's rewrite it. What am I going to write first? 2x minus 3 times what? 0 equals -6. And then I'm going to find what x is. And that's going to be my x-intercept. That's where I'm going to put my point on the x-axis. Does that make sense? All right, so what do we do? What's 3 times 0? 0. So really, what do I have? I got 2x equals what? No? -6. -6. Now, let's solve for x. One little easy algebra thing. What do I do here? Divide by 2. Right, everybody's used to this by now. So what's x equal to? -3. It's negative over positive, which is a -3. So I'll put the graph on here in a second, but let's find the y-intercept, and then we'll put them both on there. So how do I find the y-intercept? What do? I set x equal to 0. So let's do that. We're going to use this equation. Instead of writing it as x, we write it as 0. So what is it? 2 times 0 minus 3y equals -6. And let's do the math on this. 2 times 0 is just 0. And then minus 3y, or -3y, equals -6. One little step. What do? Divide by -3. You got to divide by the negative as well. Divide this by -3. They cancel out. Y equals 2. Good. +2. All right? So now, here's what you would do. You'd make a little x and y axis on your paper. Okay? And then, let's do it in a different color. Let's use this pink. I haven't used that in a while. Where is the x-axis going to be? Or what's the x-intercept going to be? At -3. 1, 2, 3. And put a point right there. What's this one tell you? That's the what? It's the y-intercept. Where is it? 1, 2. Right there. So I got a point here, and I got a point here. What do I do to get the graph? Just connect them. You got it. All right? There you go. Goes through both of them. And put arrow. And there you go. There's your graph. So it's a little extra work than what we did on the slope-intercept form. Would you agree?
Yeah.
All right. But it wasn't that hard, especially when you're making something 0. Because what happens? Like when you make x 0, what happens to it? It just cancels it out, right? What happens when you make that y 0? It just cancels it out. All right, so one little math step, divide by 2 here, divide by -3 here. Was that really that hard? Not really. So that's really all we did, was just divided this by 2, divided this by -3, put your 2 points on here, all right, connect them, boom, you're done. Is that something you think you can do? All right. One more thing, then we'll be done, okay? What I'm going to do is I'm going to take that equation and I am going to graph it using slope-intercept form. You're probably thinking, well, you're crazy, Mr. Hamrick, because that's not in slope-intercept form, is it? All right? But we're going to put it in slope-intercept form. So let's write it again. Do you remember what it was? 2x minus 3y equals -6. Is that what it was? Okay. So what you could do, here's another way, right? That was one way to do it, using x and y intercepts. This is another way to do it by slope-intercept form. What's that? It will be, but let's do the math, okay? So I want to do this in slope-intercept form. There's 2 ways to graph this, all right? And, well, there's other ways, I guess, you could graph it, but the 2 ways we're going to graph it, all right? And we're going to use slope-intercept form. That's slope-intercept form. So this is what I want this to look like, all right? I just want y by itself. So what I'm going to do is come over here and try to get y by itself. So I'm just basically solving for y. So what do I have to get rid of if I want to solve for y here? The 2x. How do I get rid of the 2x? This is a plus 2x. Remember, I'm getting rid of the whole thing. I'm not just getting rid of the 2. I'm getting rid of that whole 2x. It's a plus 2x. How do I get rid of it? I subtract 2x. And then what do I do to the other side? Subtract 2x from the other side. Everybody with me on that? Because I want to get y by itself, right? So I got to get rid of the x. So that cancels. Bring everything down. -3y equals. Now, we got to think about this. Remember, this is written y equals what? mx, then plus the b. So I want the x stuff to go first, right after the equal sign. So I'm not going to write it -6 minus 2x. How do you think I'm going to write it? I'm going to write -2x, what? Minus 6. Isn't that the same exact thing? It just looks a little nicer because it looks like this, right? The x comes first, and then the number that's sitting there by itself is always on the end. So we're going to put that -6 at the end. Everybody see that? We only did one step. All I did was just subtract a 2x, and I just changed the order around a little bit so it looks a little more like this. That's all I did. One more step, and we're ready to graph it. All right? What's that step? I got to get y by itself. Divided by? No. What's that -3 doing to the y? It's multiplying, isn't it? So it's -3 times y. How do I get rid of something that's being multiplied? I divide. So I divide by what? -3. Now I got to divide everything over here by -3. So I put this over -3 and I put that over -3. Everybody knows that rule, right? Whatever you do one side, you got to do the other side. Let's see what happens. This cancels out. What am I left with here? Just a y. Oops, come on. There we go. Y. What's this? Negative over negative. Positive. And what's a nice way to write this? 2/3 what? X. Just put it right in the middle. Okay, that means the same thing as 2x over 3. 2/3 x means the same exact thing. All right? And then what do we do here? Negative over negative again is positive. 6 over 3 is 2. So this is what we're going to graph now. Everybody see that? So let's put our x and y axis right here. And let's go different color. What haven't we used in a while? We haven't done this orange color. Let's do that orange. All right, so first thing we do is we graph the +2. Where do we put that? On the y-axis, +2. There's 2. So put a point right there. And now we look at this number right there. What do we do with that? That's my what? That's my rise over run, or my what? One word. Slope. It's my slope. That's right. Okay? So where do I start? Do I start right here at the beginning again? Nope. I start at that point. So what do I got to do? I got to rise 2 and run 3. So let's put a couple extra on there. There's the 2. There's the 3. All right? Those are a little bit stretch them out just a little bit more. It's a little closer than that. All right, here we go. So we go from here, the y-intercept, we go up 2, 1, 2, and we run 3, 1, 2, 3. Put a point right there. Now, what do we do with those 2 points? Connect them. And that graph should be exactly the same. Let's see, do I still have the graph up there? Yeah. See that graph right there, that orange one? It's exactly the same thing as that pink one. Everybody see that? Because look at the slope. Watch. Let's do that. Well, look at the slope. I go up 1, 2, and I run what? 1, 2, 3. So it did work out that way, didn't it? So that does have a slope of 2/3. All right? So this graph right here is the same as the graph above. And it should be, because it's the same equation, right? We use the same exact equation. We just graphed it 2 different ways. What was the first way we used? X and Y intercepts, okay? And then what was the second way we used? We used slope, intercept, form. Everybody okay with that? All right. There's a little bit more that we got to do, all right? I just don't want to flood you with just so much information right now. I think that's enough to get us going. Now, our lesson plans have been blown out of the water, so because I didn't give you homework yesterday and I didn't give you homework today. But tomorrow I will. I know a lot of you guys are going to be gone for football. I'm still going to teach it. All right, so make sure you watch the YouTube video. All right. I asked the other class, who's really going to watch it? And everybody's like, I'm not going to watch it. I'm not going to watch it. I was like, well, at least you're honest. But you need to. All right. If you want to know how to do this stuff, you got to watch it. So if you're going to be gone, all right, and we did stuff in class, you got to go back to the YouTube video and watch it. All right, so I will assign the homework tomorrow, so it'll be due on Monday. So whatever is on Wednesday on your lesson plan this week, that's where we are. Everybody got that? Because I kind of underestimated how much stuff we have to do with 3-5 when I was doing the lesson plans. I should have known a little bit better, but that's okay. We'll adjust. All right, yes. Don't you add them? I don't know. On the last one, you don't add anything, really. No, you're not adding anything on that. All right, enough of that. Everybody good? All right.